you doing?
Good. You?
Doing good? I'm doing great. Did you have a good Halloween?
No. Yeah.
No, but yes? What did y'all dress up for Halloween?
Nothing.
You were yourself.
I stayed home.
That's not a scary costume at all, though, Miss Roxy. Huh? You got sick during Halloween? Oh no, it wasn't bad candy, was it? You think so? Oh my goodness. All right, make sure that you are cutting out your items. Please know that I have made the dates and the lesson title much bigger. They still fit in the wide ruled. If you're using wide ruled paper, they still fit. And they definitely are much bigger and easier to see for the top of your paper. So hopefully that helps you out. As you're cutting, this blank graph you can set to the side in your baggies. So put this graph, ladies and gentlemen, this graph right here, put these in your little safekeeping baggies. We'll use them another day. Not today, maybe not tomorrow, but another day. I'm sorry?
Which one again?
The blank graph.
This one?
Yes, sir. Do you have scissors, Jesse? There's some over there. There's none. There's no more.
Right here.
Here's some. Handy, will you pass them those scissors, please? Thank you. Maria, do you have scissors, baby? No. I think there's a. There's no one there? Okay, scissors are on their way. Thank you, Miss Padilla. Always a huge help.
My partner's not here.
Your partner in crime is not here. Oh, no.
Yeah, me. No, man.
Candy, I'm right here.
What is it then? I do not want to.
Cut quickly and share, please. Cut quickly and share. Sunny and share. I don't know. Who's out in the restroom? Do I have anyone out? No, I don't think I have anyone out. Is the pastor? The pastor's there. All right. Okay, so these are the 3 items that we're going to be using today. The line segment with the big dot, and they are together, so don't cut them separately. Keep them together. We're going to be using the hexagon. Side conversation later. And we're going to be using the rectangle on the grid. Okay. Take a moment to update your table of contents. No, that's going to be the homework. I have another glue stick right here.
Are you ready?
You ready, Maria?
Oh, I'm not a good
Like that better? We can see it. Look at that. Pretty good. All right. So last week, the last time we did lecture, we did rotations, and we talked about the different angle classifications, and we added one new one. We had all of the vocabulary for rotations. We had transformation. We talked about isometric transformation, which is a transformation, a change. that size and shape get saved. We did a rotation construction, and a lot of you showed me some of your attempts on those. And then we did the algebra rotations, and a lot of you, I think most of you did these and did really, really good with the algebra rotations.
I did good.
Yes, you did.
Yay.
Leave a page for your KWL for this particular lesson, and start your notes on the very next page. Today we'll take up 2 pages for notes, so please prepare 2 full pages for notes. Today is Monday, the 2nd of November. It's my daddy's birthday. Unless we're feeling particularly mean. He was born in Mexico. And in Mexico, when a baby's born, the parents have a certain amount of time to report the birth for a birth certificate. Otherwise, they have to pay a fine. Well, my grandpa kind of missed the deadline for my dad's October 2nd birthday. And so instead of paying the fine, he wrote down that my dad was born November 2nd. And so some years, my dad gets 2 birthdays from us. We have a party on October 2nd, and then we have a party on November 2nd, and he's very happy. But a lot of the years, we decide to troll and be mean and make fun of him. And so on October 2nd comes around, he's like, "It's my birthday." And we're like, "No, your birthday's November 2nd, Dad." And he goes, "Oh, okay." And then November 2nd comes around, and he goes, "It's my birthday." And we're like, "What are you talking about? It was October 2nd. And he doesn't get a party from us. We still give him cake, and we hang out. Yeah. We like to be mean to him. So say happy birthday to him so I can put this on the recording.
Happy birthday! Happy birthday!
Doesn't he watch your videos?
He does on occasion. I'll send him, I'm like, "Hey, I had a really good recording, really great class. I want you to hear this." And then he used to be a math teacher as well. He's retired. So him watching my videos comes with, there was a better way to explain that, Mijita. Okay, Dad. Huh?
What's cool?
He taught at a lot of different schools. He was in Brownsville, McAllen, Mission, FAR, San Juan. I think his last high school that he retired from eventually was Science Academy here in Mercedes. So
When you were young, you were always moving houses or
no, my parents were divorced, and so I lived with Mom in one house, and Dad drove all over the place wherever he needed to go for work. So, yeah.
Little con.
All right, so what objective is I will draw and describe dilations. Yes, ma'am, who are you looking for? Who? Andy.
Go ahead. Wait, do I take my stuff?
He'll be right. All right, back with me, please. Back with me, please. Thank you, thank you. So we're going to be describing and drawing some translations, gentlemen. Stay with me, please. Thank you, thank you. Okay, so here's some regular sheets of paper for you. Okay, so just write it on that, and then you can fill it in later. And we're going to calculate using something called the scale factor. I want to start off today with a recall. What was a transformation?
It's slide. Wait, no, never mind.
What was a transformation? Like Transformers, what did they do?
Transform.
They change. They change from a car to a robot and a robot back to a car. So a transformation very simply is a change. Now, last week when we were talking about the rotations, we formally defined the idea of an isometric transformation. That's where our image ended up the same shape and the same size as our pre-image, the thing we started with. And so I want to start our conversation of something new today on the idea of a non-isometric transformation. So if an isometric transformation saves size and shape, it just puts it in a different place, What does a non-isometric transformation do?
It's not the same.
It's not what?
Same.
It's not the same. It doesn't save size or shape.
He says nothing.
It doesn't save size or shape. My geometry professor in college really loved working with these non-isometric transformations. And his favorite one, the one that blew my mind and made me go, wow, this is really cool, was he would take a donut, okay? Not the chocolate glazed kind, okay? He'd just take a donut and he'd transform it into a coffee cup. Yeah. He said that, and I looked at him and was like, no, sir, no. And he goes, yeah, look. And he took some Play-Doh and he made a donut. And I was like, okay, I agree with you, it's a donut. And then he mushed it around, and he didn't tear it, and he didn't add any holes to it. He just mushed it, and it turned into a little coffee cup with a handle. And I was like, whoa, mind blown.
A real donut or like a fake one?
Well, a Play-Doh donut,
Oh, that was like a
okay?
real one.
Yeah. We haven't figured out how to turn yummy, delicious dough into chunk can drink out of it yet. So we're still working on that. But we could make the shape change. And that was really cool. And then he showed me some of his computer animations for it. And I was like, oh, this is super awesome. And then he showed me all the squiggly math symbols behind it. And I was like, yeah, no. I love you, Prof, but I'm not taking that class. I'm sorry. It's over my head. He's like, oh, man. I was like, well, I'll take the intro class. Okay. He's like, all right. We're not going to turn donuts into coffee mugs, though I will probably make some Play-Doh and bring it in so that we can give it a try and just play with it, which sounds like a whole lot of fun. What we're going to work on in this class is a similarity transformation. And I think there's more than one kind of similarity transformation out there. Please hit Google and let me know. What a similarity transformation is it's a proportional change. It's a proportional change. What this means is that if I've got a box of some size and I change one side of the box to be, say, 2 times bigger than it was before, all the sides of the box have to now be 2 times bigger than they were before. Okay? If they don't grow that same way, then they can't be a proportional change. Yes, go on, help yourself.
Visitors. Right.
If I don't have any more, you can look inside the supply closet.
Let's look at mine.
You'll give me yours? That's very sweet of you. Okay. Thank you very much. Thank you. So it's a proportional change. All the sides have to change in the same amount, okay, as all the others. The similarity transformation that we will be studying today is the dilation. So a dilation, this transformation, it is a similarity transformation, which means that all the sides are going to grow in the same rate, at the same size. And we've got 2 different kinds of dilation that we can talk about. We can talk about an enlargement dilation, which means the image we end up with is going to be bigger than the one we started. And we can have a reduction dilation, which means that the image we end up with is smaller than the one we started with. So we have an enlargement dilation and a reduction dilation. I'll give you all a few minutes to finish writing. A few moments, rather. Do you need paper? Do you need paper? Okay. Be writing with us, okay? Thank you. All right. There's 2 things you have to keep in mind as you're looking at dilations and things that you need to really think about in terms of creating and describing. you have to talk about the center of dilation. Just like the center of rotation is this fixed point and everything's spinning around it, the center of dilation is also a fixed point, but it's where the growing or the shrinking is coming from. So the center of dilation is the fixed point from which the dilation happens. That's supposed to be an M. Is anyone in art?
I wasn't.
Yeah, we got quite a number of people in art. Did you take it last year?
Yeah.
Yeah? All right, so that's almost everyone who is currently taking art or took it last year. Okay, those of you who are in art now or were in art last year, do you remember that one assignment where you had to do the perspective thing?
Oh yeah.
Yeah.
And you had to draw all the lines going to this one point way out?
Yes.
It was hard.
What was that point called?
2 point, 1 point, and 3 point.
It was tough. It's like 3D.
It was like, yeah, it ended up making it 3D, but do you remember what that point was called?
Intersection?
Was it intersection?
No, it's
Oh,
not.
God.
Focal.
Like a focal point?
Yeah.
Also could be called the vanishing point.
Yes.
Because that's where it looks like everything is vanishing toward. Okay? So in this class, as you were talking about the center of dilation, it's okay to call it a vanishing point. You'll see it in directions, in homework, quizzes, tests, that kind of thing. You'll see it written as center of dilation. But it's the same thing as the vanishing point from your art class. Okay? And if this was hard for you when you did it, hopefully after this explanation, it'll be easier.
I
Okay?
didn't do that though.
Huh?
I didn't do that.
You didn't get a chance to do it? Well, you'll get a chance to do it now.
I just
Oh, no,
missed it
like,
today.
I had a choice.
Oh, you had a choice and you chose something else? Okay. The other thing that you need to think about in terms of center of dilation, or in terms of dilations, is the scale factor. So if the center of dilation tells you where you are starting to grow from or shrink towards, the scale factor tells you how far you are growing or shrinking. It is the number by which the dilation occurs. So it'll tell you how far you're, how small you're getting or how big you're getting. Okay? That's our scale factor. Calm down, calm down. Let's set up for our first example. This example, you will need the dot and the line segments. Oh. All right. Here are the directions for this example. We're going to draw the dilation of line segment AB centered at S, point S, by a scale factor of 0.5 or 1/2. There are 4 steps to drawing a dilation. Bless you.
Thank you.
There are 4 steps to drawing a dilation. We will write the 4 steps first, and then we will draw it. Giving everyone a few moments to finish drawing, or finish gluing the drawing and writing the directions.
That is 0.5.
It does say 0.5, yes, sir. So our scale factor is a 0.5. All right. I'll show the directions again in a little bit if you're still missing a few words. Step 1. Step 1. Step 1. Draw some segments from every important point on the pre-image to the center of dilation. So you'll be connecting the center of dilation with every important point on your pre-image. And by important point, I mean endpoints, if you're looking at a segment, or vertices, if you're looking at some sort of shape like a triangle or a square or a star or something. Okay? So all of your important points, a thing that'll help you draw it. Okay? That's step 1. Step 2 will be to take your ruler and to measure those segments that you just finished drawing. I suggest that you jot down the measurements as you go. And you'll see it once we get there. Step number 3. Multiply those measurements by the scale factor. So whatever number you got is the measurement, you multiply it by whatever number you were given as the scale factor, and you'll jot those measurements down as well. The last step.
Attention juniors and seniors, if you got an A and B honor roll for the first 6 weeks, please report to the cafeteria at this time. Juniors and seniors only.
The last step is to mark out the new measurements so that you know where the points are going to end up after your transformation. Okay? So, draw segments, measure segments, multiply by scale factor, mark the new measurements. Here we go. Take the protractor. And step 1, draw segments from every point. Now look at point S. It's a gigantic point. Pick a spot somewhere on that black splotch that is point S and let that be the location. And just send all of your lines to that spot. I went a little ham with, with the, gotta make this thing bigger. Okay. So there it is, and I've apparently made my point right over there in the back. Okay, it's right here in the back. All right, taking my protractor with its ruler, I'm going to measure line segments SA and line segment SB. Not using distance formula, I'm just using the ruler. Now I'm going to use the centimeter side because for me it's easier to get decimal points when I'm using the centimeters than it is for me to get decimal points when I'm using the inches. If I'm using the inches and I have to get a decimal for like 3/8 of an inch, my brain leaks out of my ears because I have a hard time thinking about how to do that. Okay? Especially when I'm going quickly. So I'm going to use the centimeter because each of these marks is 1/10 of a centimeter, so I can easily read it as 4, 0.1, 0.2, 0.3, 0.4, 0.5. So segment SB is 4.5 centimeters long. Repeat for line segment SA. It should be the same length, but I don't really know. I've got to remeasure it. Mine ended up being 4.8. Yours is going to be a little different. Just depends on where you chose your location in the big splotch that is point S. I mean, all of us are going to have something a little different. All right, so we've measured it. Step 2, that was step 2. Step 3 says multiply these measurements by the scale factor. Okay? But I want to show you how we're going to document that we're measuring, that we're multiplying. What we're going to do is we're going to write out S to A prime. Because remember, this is a transformation. We're moving point A somewhere, And the place where we're going to end up moving it is going to be called A prime. So the distance between point S and A prime is the scale factor, 0.5, times the original distance between S and A, 4.8 centimeters. Put that in your calculators. Grab your superhero that's on your desk nearby. 0.5 times 4.8. Who did you get? Wasp and Captain America. Awesome. We got some Avengers back there. Very nice. You got Tony Stark and Ant-Man. This is the Avengers side over here. I've got Thor.
Who's the Hawkeye?
Wasp is, okay, did you see the Ant-Man movie yet? Did you see the Ant-Man movie yet? No? Okay. She's married to, well, related to, depends on the story. She's with Ant-Man. You got Hawkeye. Selena Kyle, that is Catwoman. She's really in tight with Batman. So who's got Batman?
Me.
You got Batman. You don't?
Spider-Man.
You got Spider-Man. Okay, so this really is the Avengers Central. Who do you have, babe? Who do you have?
Oh?
Who do you have?
Carol?
Carol
Dan.
Danvers. That is Captain Marvel or Miss Marvel, depending on what you're in. She's also an Avengers, so you got the Avengers on this side of the room. That's pretty cool. I did not do that on purpose. Huh? Yes, Spider-Man could eventually be an Avenger. We'll see. All right, so what did you get, Avengers?
2.4.
2.4, say the Avengers. Awesome.
I have a different number for the SB.
Okay.
So I just write it.
Yeah, you just write whatever you got. Yes, that's right. Okay, so that's SA. So what we're going to do is we're going to measure. S is 0 again, and we're going to measure toward A, but this time I'm only going to go 2.4 centimeters. So 1, 2, and 4. So here is where A prime ends up. Repeat for the other segment. SB. And I'm going to look at this side of the room. What heroes are on this side of the room? Because we know the Avengers are all over here. Who do we have over here? Yes. This is Aurora Monroe. She's an X-Men. That's Storm.
I am her.
Scott Summers, Cyclops, another X-Men. So we got some X-Men going on over here. Lala, who do you have? You have Deadpool. He can go anywhere, dude. He's free spirit. Maria, what's the name of your superhero? Barbara Gordon. Oh, we've got some Bat family going on here. Anin, who do you have?
Oh, I already told you.
Oh, you told me. I forgot. Selena Kyle. Selena Kyle, that's Catwoman, yeah. So her and Barbara Gordon are in the same kind of storyline. All right, so we got X-Men, the wild card, and then some Batman going on here. There's a bit of joke. I don't have a Joker right now. Anyway, so X-Men and my DC Comics. Can you tell me what my new SB prime is going to be? 0.5 times 4.5? Scott Summers getting pulled out. Cyclops working hard.
Oh, it's 2.25.
2.25 says
2.3.
Catwoman. 2.25 says Catwoman. Cyclops, do you agree? She's thinking. Yes, Cyclops agrees with you. For once, DC and Marvel agree. All right, so I'm going to go back to my point S, and I'm going to measure out 2 centimeters and then 0.25. And then, as always, when I'm doing my constructions, as soon as I have some points, I'm going to connect them together. And there we've drawn the dilation of line segment AB, centered at S, with a scale factor of 0.5. Notice that it's smaller than the original. Do you notice that? All right. All right, come with me over to the next page. And we're going to set up for our final example for the day. You guys are doing good on time. We've got about 20 minutes left in class. I want to try to finish this example in, say, 15 or less, so that I have time to give you the directions for an easy 100. All right, so the directions for this state, excuse me, the title. I'd like the title for this example to be, I'm sorry? Okay. Dilation. Yeah, it's a D. Dilation on the coordinate plane and add to the title centered at 0, 0, the origin. So just like the rotations and the reflections, when we had this thing centered at the origin and we were on the coordinate plane, we got to do a little bit of algebra, and the rules were really simple, right? Just like multiply by a negative here, it flipped the x and the y's on this one, and you were done. There was very little thinking involved. This one has the same amount of thinking. Take the x and y coordinates, and what you need to do, if you have a different colored pen, please pull that out now, is you're going to multiply the x coordinate by some number, which we're going to call a, and you're going to multiply the y coordinate by some number, the same number, so we're going to call it a. And that's all you do. You're just going to multiply the coordinates, and whatever new coordinates you get, that's where the dilation ends up.
How do you multiply the 2 by x? Or like, I'm just saying.
Yeah, you're going to see it on the example. You'll see what, because a is going to be a number, and x is going to be a number, and we just multiply those two numbers together.
So basically like the same numbers for, so like, it's the same, so it's going to be like 2 times 2, and then y is going to be like 3 times 3.
Well, you'll see. When we do it, it has this number here, a, has to be the same number. So if it was 2, using your example, then I'm going to do 2 times whatever x was, and 2 times whatever y was.
All right.
And that result will give me the new coordinate. Okay? I need to give you a little bit of information about what this number a is, though. This number a is the scale factor. So if you were using 2, your scale factor would be 2. Right? You ready to do this example?
Yes.
All right. Scooting it over just a little bit. She's got you hooked up.
What way?
All right. So, dilate rectangle ABCD centered at 0, 0 by A equals 1.5. What's our scale factor?
0.1, 1.5.
Our scale factor is 1.5 because that is the value of A. All right. Let's look at point A. So point A is 2.4. Yes? So so to find the coordinate of A prime, we're going to take 2 and we're going to multiply it by this value A here. So we're going to take scale factor A and multiply it by the x coordinates of the A point.
Wait, so why is it 1.5 though?
Because that's what was chosen.
Okay.
Yeah. And to find the y coordinate for A prime, you're going to take that same scale factor and multiply it by your original y coordinate. So it's going to look like this. 1.5 times 2. And 1.5 times 4. So our new coordinates for A prime are,
3 and 6.
superheroes help me, 1.5 times 2,
3, 6,
3,
and 6.
and 1.5 times 4.
6.
Ooh, the Avengers over here are fast.
Oh, sweet.
Batman people, and X-Men. Let's go.
I'm Hawkeye.
You're Hawkeye?
I'm Iron
All right, so let's graph our new points. A prime is going to be at 3, comma 6. So here's 3, 2, 4, 6. So A prime ends up right there. Repeat this process for every point. All right?
Yeah, but I could just, wait, I don't understand.
Okay, let's do it again with B. Here's your coordinates for B.
Yeah, but like, why is it 1.5 then? Like,
That's just the scale factor you were given.
so I'm gonna have to multiply that every time?
To everything, 1.5. The scale factor is always the same because this is a proportional change. It's a similarity transformation. So once you're given a scale factor, you use that scale factor on everything. All right, see if you can beat me. Get to the graphing before I do. You do not have to write out all of the work. If you want to shortcut and just type it in, you can. When you're doing your work, you do need to show just enough for me to go, oh, yep, you know what the scale factor is and you know you're supposed to multiply. Awesome. Okay? But since I'm the teacher notebook over here in the example, I need to show like all of the steps. And I'm going to pull out my own superhero. I'm also using an Avenger today. I have Thor.
Oh, we're doing them all?
Yeah, do them all. And see if you can beat me, if you can get to graphing them before I do. I'm going to try not to mess up here. Challenge accepted. On me not messing up. There are my coordinates for D prime. All right, and as always, you're going to grab your straight edge and connect the dots. All right, here we go. Does your dilation look something like this?
Yes.
Yes? Okay, I did it right. Yes. Fantastic. All right, so our first dilation, the scale factor was smaller than 1, wasn't it? It was 0.5.
Yep.
And this dilation, 1.5, the scale factor was bigger than 1. What do you notice?
The bigger is the B.
The bigger the scale factor, the larger it grows. And if the scale factor is larger than 1, is it going to be an enlargement or a reduction? An enlargement. And if it's smaller than 1? A reduction. All right, let me give you the directions for this item, and you will finish it tomorrow, okay?
Yeah.
All right. Anyone need the rest of this copy down, or did you get it all?
Yes.
Okay, here you go. There are your coordinates in your work. I'm going to give you 1 minute to copy this down, and then we'll get to the directions for tomorrow's assignment.
Miss, I need the ones from the side.
You need the ones from this side. This direction?
Yes.
I'm going to zoom it out just a little bit.
I didn't get any either.
There you go. Can you see it from there?
Probably got it for
Okay.
Discrimination. Discrimination.
What? Look, all Avengers together, okay? Y'all are a team.
We're splitting up.
You're splitting up. No, don't break up the Avengers.
Actually, they do. They do.
I know. We have East Coast and West Coast. Break my heart.
But they come back in the civil war between Captain America and Spider-Man. When Spider-Man come out.
Spider-Man's coming out in that one?
Yeah.
Oh, right on. Now I'm super excited to see it. Who do you guys have in the back? I didn't get to hear while they finished copying.
The civil war between Captain America and...
You have Nightwing. Okay, so we've got another Batman back there.
They're fighting.
You have the Hulk. More Avengers. Winston, who do you have?
Hey.
Winston.
Hey, Miss May.
He is who? Who do you have? Who's your hero? Who's your superhero? Jay Johns, the Martian Manhunter. Also part of DC, also works with Batman. All right. Here we go. Here are your directions for tomorrow. This is the item that you must have completed before you leave the class tomorrow. Tomorrow will be a work day for you. This will be a notebook check grade, notebook check number 6, all about dilations. And this will be the final grade for this 6 weeks. So I will pick it up tomorrow, and it's either 100 done or it's not done. Okay? Yeah, let me finish this up and then I'll try to get it to you. Here are your directions. Dilate the hexagon MPRVWS. Look, I'm not making it up. That's really the hexagon's name, okay?
Wait, this is the new one?
This is a new page. Dilate hexagon MPRVWS centered at point S by scale factor. You tell me.
8.
You can pick any scale factor you want except don't pick 1. Think about this a second. Why should you not have a scale factor of 1? Yes, the same thing. It doesn't do anything. Also, don't use a scale factor of 0. Why not?
Same thing.
It's not the same thing.
Actually, there won't be none.
You multiply those distances by 0, which means how far away are you from the center of dilation now?
None.
You're not away from the center of dilation. You're 0 away from it, which means it all shrinks down into the center of dilation and turns into a black hole and poof, disappears. So don't pick 0 and don't pick 1, but anything else is fair game. Here's the hard part. You ready? Think what scale factor you want to use.
7.
6.
And if your scale factor, you've got to figure out where you're going to glue this down. Okay? You get to glue it down anywhere on the paper you want, but keep in mind your scale factor. You've got to glue it down somewhere that once you've chosen your scale factor, it's not going to run off the page.
What do you mean?
So if I glue it right here and say scale factor of 2, this is going to end up in here, and I'm going to end up
Okay.
writing on my work.
Look how big, man.
Are you going to be able to stay on the page? And if you're not, how are you going to add more paper so that you've got room? Okay?
We're gonna do it like that.
Yeah. Now you are welcome to use a small scale factor of like 0.3 or 0.1. But just remember, the closer you get your scale factor to 0, the smaller the thing is going to get. Okay? So please don't pick a scale factor of 0.00000001. Okay? It's too small. Pick something bigger.
Yes. Yes.
All right.
Can I pick 150?
You can pick 150.
Oh, damn.
All right. That's a lot of paper.
Challenging something.
Have fun.
A million.
All right, I want to see your dilations tomorrow before you leave. You will not be released tomorrow until you've shown me your dilation, and that will be your last grade. After that, I'm locking it in. So any assignments that you were correcting or are missing, please get them turned in at the start of class tomorrow so that you can work on this during the class period. All right? Thank you very much. Class is over. You have 4 minutes.